Okay, so in this lesson, we're now going to look at using the right analog stick to actually shoot the bullet. Now, the reason why we aren't going to mess with fixing the direction that the character is facing yet is because ultimately the direction that you're shooting will override the direction you're moving. So if you are moving to the left, but you're firing to the right, your character will face to the right, even though they're moving to the left. So there's really no point in putting anything into place now to fix the movement when ultimately it's going to be based on the shooting. So we might as well get that into place first. So what we're going to do is we're going to take our bullet, we're going to put it into the scene, and let's just move this a little bit forward. It doesn't matter. I just want to be able to see it. And let's shrink it a little bit. Run that really quick. That's a little bit big, but let's drop it to 0.7. Okay, good enough. Now I'm going to quickly add a particle system to it. This is not meant to be a particle system tutorial. I have other ones for that, but you can always just pause the video and choose the settings that I choose. So game object, particle system. We're going to shrink the size. We're going to reduce the lifetime. We're going to reduce the speed. We're going to increase the emission. We're going to change the, well, actually, we're going to keep the cone shape. What we're going to do is we're going to reduce the circumference, both at the top and at the bottom, and then the top as well. And this still lasts way too long, so let's make it a lifetime of just 1. Let's make it like 0.5. And then what we'll do is size of a lifetime, just click there, create a keyframe by right-clicking, and then move the right dot over, because what you're doing is you're saying, okay, don't shrink, don't change the size over time at first, and then starting at this point, then go ahead and change the size over time. So what you can see is by doing that, rather than just disappearing, it shrinks. All right, so that's just about it. So we said the bullet is at 0, 0, -4. So let's put this also at 0, 0, -4. Take a look. We'll shrink the base just a teensy bit more. And now what we're going to do is we're going to take the particle system, drag and drop it onto the bullet. That makes the bullet the parent. Click on the bullet, add physics, rigid body, get rid of gravity. Now we can apply momentum to the bullet just like we do the player. So go ahead, take that, drag and drop it into the asset area, and that creates a prefab. We can now instantiate it or spawn it whenever we want to. Okay, so far, so good. Now what we need to do is we need the player to shoot the bullet. So let's go back to our hero controls script. And what we need to do is, just as we put the input from the left analog stick into those variables, we need to put the input from the right analog stick into the other variable. So xfire equals input, again, because we're looking for player input. What kind of input? It's an axis input. And which one? It was x shoot, 2 O's. Oops, sorry, that's supposed to be in quotes. And then Y fire, again, input, get axis, y shoot, two O's, in quotes. We'll save that. So now the controller value is being dropped into these. However, whereas we directly applied the value to the velocity, we don't want that. The velocity is going to have the same speed, okay? It's just which direction do we want to fire it in. So we're looking more for positive and negatives as opposed to the actual value. We just want to know, is it a positive value or is it a negative value? And that will determine the direction it's going to move in. So first, we need to have the character be aware of it. So going to add two variables. Sorry, I think I did this in between videos. So in the hero control, add public transform bullet shot, public float shot delay. It's a transform, so this is going to be the variable to store the prefab, and this is going to be used to make sure we don't shoot too fast, because you need a delay. You don't want to have too rapid a fire. You want at least some kind of pause in between them. So we'll save that. And if you come over to the player, you'll see that bullet shot is there. So just drag and drop it, put it onto it. Now, the player character, so the player object, is now, for want of a better term, aware of the prefab, and it's aware of it through the bullet shot variable. So it can now spawn or instantiate that prefab over and over again. So far, so good. So what we want to do is we want to say if xfire is greater than a certain amount, say 0.2, because we won't want it to be too sensitive. Or, so that's the pipe, a double pipe, it's above the enter key. Xfire is less than negative 0.2. So if it's greater than 2 or less than negative 2, we want something to happen. We want to instantiate the bullet. Same thing for Y, but we also are going to have the rotation be affected as well. So let's copy that, paste it. So if Y fire is greater than 2 or Y fire is less than negative 2. Okay, so to spawn, it's called instantiate. You have to give 3 arguments. What is instantiated, where it's instantiated, and the rotation. So what is being instantiated is that variable, bullet shot. Where it's being instantiated, let's have it instantiate where the player is. You can get the coordinates of the player by just typing transform.position. So transform.position is actually a vector 3. It stores x, y, and z coordinates without actually having to type out x, y, and z. This just says whatever position the object is that the script is attached to, that's what we want. And drop it into whatever we're putting that transform.position value. And then the rotation, we want to use the bullet shot's own rotation. Same for this. Now you can say, well, you're doing the same thing. Why separate it? I think what we're probably going to do is actually break these up into 4 separate ones and alter the rotation as well. But for now, that says to instantiate. So now what we need to do is create a separate script. And we'll call this a right-click, create, C#, and we'll call this shot control. We'll click on our bullet, drag and drop shot control, and open that up. So what shot control is going to do is it's going to move out in the direction based on the value from the controller. Now, even though these are all local values, any object can read the input from the controller. So what we're going to do is we need to do two things. We need to rotate the object in the proper direction, and we need to give it velocity. So, and this should happen in the start section, not the update section, because we want it to be applied the moment it's instantiated. So get component. It's going to be the rigid body that's attached to the bullet. We're going to change the velocity. And what are we going to change the velocity to? Well, that's going to be based, sorry, that's the vector 3. That's going to be based on the direction the player is facing. Sorry, not the direction the player is facing. The direction on the control pad. So this script also needs to be aware of the right analog stick. So what we can do is we can actually use these variables again. Since they're not static variables, we can just like copy and paste these, and it doesn't cause a conflict. Because even though it's exactly the same syntax, it's an entirely different variable because it's not a static variable. Which means we can copy this as well. All right, so we've created two variables. We've dropped the value of the variables. Dropped the values of the axes into the variables. Now, we can't just put the variables in here like we did here, because we wanted the velocity of the player to vary. We don't want the velocity of the bullet to vary, though. What we want to vary is the rotation. So what we want to do is we're going to modify xfire. So if xfire is greater than 0.2, then xfire is going to be set equals 5, because we need the velocity to be faster than the player. The player is moving at a velocity of a maximum 3, so we want it to be faster than the player, or there's really not a whole lot of point to it. Likewise, if xfire is less than -2, again, we're trying to, we want that threshold. And then repeat for y. So if yfire is greater than 2, then yfire is set to 5. If yfire is less than -2, then yfire equals -5. So in other words, we're taking the value and we're increasing it because these are variables. Okay, so the value changes. We're going to take that and change it to a constant based on the range. So if you're moving in a right direction, they're going to set it to 5. If you're moving in a left direction, it'll be set to -5. Moving up, be set to +5. Moving down, -5. Now we can just drop the x and y fire values right in here. And I believe this should now work and fire in all directions. It's going to rapid fire, so you're going to see too many of them. So that's why we added that delay variable, which we'll get to in just a minute. All right, let's see if this works. So I'm going to walk around with the character and move the controller. And there we go. And now, like I said, it's rapid fire, so it's too much. And we also have to handle the rotation. But look at how quickly we get the basics of a twin-stick shooter. All right, so first things first, let's go back to here and add in the delay. So right now we're saying if you're pressing in a direction greater than the threshold, go ahead and fire. Let's add an additional condition. We're going to say, so these two are ORs, so either one of those can be true. But we also want to add an AND. So one of those has to be true, and this next one must be true. And that is shot delay. and shot delay. So it's going to start at 0. So if shot delay is equal to 0, double equal sign. So that way it shoots once, and then shot delay will then be set to 1. That way it shoots and then won't shoot again because this value has changed. So same thing here. Got to get the parentheses right. Okay. So now, as it stands, it will shoot once horizontally or once vertically, and then that's it, because this number is then changed, and these will no longer be true. So we now need to add the actual delay. So outside of start, outside of update, in its own section, we're going to put in enumerator. And we're going to create, let's call this delay reset. What does it do? All right, so don't worry too much about these 3 words. Yes, you have to type them in, but as far as functionally, this is what you care about. You're waiting for a period of time measured in seconds. We're going to say 1 second. All right, then what happens? Well, then shot delay gets reset back to 0, and now you'll be able to shoot again because this number is 0 again. But unlike update, unlike start, this does not automatically activate. You got to tell it to come down here. So that is done by start coroutine, and then in parentheses, the name of enumerator routine, delay reset, also with its own parentheses. So not quite done. This will give us the delay, but things will still be shooting with the wrong rotation. So let's give this a run. See, much slower. So that's probably a little bit too slow. And as a heads up, this can be a variable. So what you can do is if you want to give someone a power-up that's rapid fire, all you have to do is put a variable in here and then change the value. If you use a decimal, you have to put the letter F in there. We'll run it one more time. There we go. A little bit faster. Again, they're shooting with the same rotation, so the rotation needs to be adjusted here. So get component, transform, Euler angles. Now, what the Euler angle does is it completely ignores the current rotation and sets an absolute rotation. So you're not rotating a relative amount. You're starting at 0, 0, 0, and you're saying, okay, here's what I want it to be. So it ignores the current rotation, whereas there's a separate rotate command that is relative, and that is, okay, whatever its current rotation is, rotate it by an additional amount. So it's important to distinguish between what the rotate command does and what Euler angles do. So, and again, this is attached to the shot. So it's the shot that's getting rotated, not the player. So we want to base it on the direction the controller is facing, but we've already changed this. So it's really only one vector we're rotating. Think we're rotating on Y. We'll find out soon enough. So let's just create another variable. So public float shot rotch for shot rotation. And right in here, we'll say what the rotation should be. So since this is a positive direction, then the shot rotation would be 90, negative 90. And actually, in one direction, it's going to be, so it defaults to facing, was it facing down? So if you're moving down, that's the default rotation. So, or not moving down, but shooting down. So shooting down is a negative Y. So in this one, it would be rotated, shot rotation would be equal to 0 because it's already facing the right direction. I believe this would be 180. So two things. A, I might have flipped the negative and the positive. 2, I might apply it to the wrong variable. So just bear with me as I give this a quick test. So this is, let's try 0, comma, shot rot, comma 0. Let's run it. And then if this works, that will basically be it for this lesson. Oops, got an error. Yep, I just forgot the semicolons. That's an easy one. Like that, it's the last one you choose. Okay, so if we up, nice, perfect. There we go. And there's your twin shooter. Now, if you're doing diagonals, it's not right. So the question is, do we want you to be able to shoot in a diagonal, or do we restrain it to just the 4 directions? Sounds like what we probably could do is we would actually add a second rotation. So right now we're just rotating, well, what we're doing is we're rotating, we would actually use the same rotation, but rather than having there only be 4 settings, there would be 8. So we'd have like the 45s, the 135s, the negative 135s. And so, yeah, we'll leave it like this for now. I don't want to do too much in one video, but you get the idea that basically this is set for 4 directions. If you want to do something in between, then you would have to have 8 possible combinations for this. All right, so that's good. So now we've got the independent motion and shooting. We'll clean up the shots and as far as the rotation of the character in the next video.